Hello and welcome to this video tutorial for Puzzle C. Through this puzzle, you will explore a little bit of a mathematical topic called graph theory with your students, but don't worry, no prior math knowledge will be needed. But you can think of the houses and roads and neighborhoods as nodes, edges, and subgraphs, respectively, and vice versa if you ever need to in the future, and you're welcome. Okay, so this puzzle gives you an opportunity to connect with each of your students. For example, you could talk to them about what it's like to go to college. You can take this opportunity to talk about how UCI is actually connected by the ring roads, and so in that way, it's kind of like a neighborhood in this puzzle. Or perhaps you could ask your students about where they live. Do they live in an apartment building? Do they live in a house in a neighborhood? Can they bike to their friends' houses? Things like that. Okay, so let's get into the solution of this puzzle and how maybe you might want to guide your students toward this sort of solution. We want to start by motivating this, and here's a suggestion that I just came up with while I was thinking about this video. Look at these houses. Pretend we are the new city planner, and the mayor of the town has asked us to help her build roads to connect every neighborhood and every house so she can drive between any two houses. She has challenged us to complete this task by building the fewest roads possible. You know, money doesn't grow on trees. Roads cost money to build. Okay, so this is kind of a challenging puzzle because you're not given like numbers and things to work with concretely. And so it's maybe not immediately clear how you start solving this puzzle. So your students might not be sure what to do, and you can suggest things like, well, maybe we don't have to think of like the whole solution right away, but if we want to connect two houses, like say this house and that house, then we want to draw a road between them. That might be a way to start counting the number of roads that we could draw total. So maybe this is the first road we draw, and then we could draw a road between these two houses. This is like the second road, but we don't need to draw a road between the house at the bottom of the screen and the house that I just circled with green, because it already has a road between them. Look, there's this road here that already exists between these two houses. And so we don't want to tear up the road that already exists there and make those people really unhappy with the construction outside their homes. So that's unnecessary. So we don't need to do that. So whenever we see this dotted black line, we know that a road already exists there and we don't need to build one. So we don't need to worry about that. And so you could ask your students, well, let's just keep drawing. Let's just take the first possible solution we think of and just see what happens. You don't have to be right away. That's okay to be wrong. Making mistakes is an important part of learning. So this is 3, this is 4, 5, 6. Oh, but you know what? I didn't have to choose this house as the next house to connect. I could have chosen this house here, as a matter of fact. When your students get an opportunity to make a choice, maybe ask them, oh, why did you choose that one? In this case, it's kind of a trivial thing, but maybe the students can think, oh, well, what if I only had these two disconnected houses and the rest of the graph didn't exist? Then I could have chosen road 6, or I could have chosen this road to connect these two houses, and then maybe this other road here. Invite them to consider the possibilities, the alternatives to the choices that they make, and to have them verbally justify to you why they chose the particular roads they did. They don't have to have a good reason, but it's good to get them thinking about choices that they're making them conscious of these choices. Okay, well, let's continue on. And I'm going to choose this to be road 7. And you can have your students count along with you, or you can have them draw in their books, in their workbooks, or on the whiteboards, and keep track of that 8. Maybe you have a student count the number of roads that you draw, or maybe you have one of their friends count the roads as the other friend draws the roads. 9 and 10. Well, I have to draw this 10th road because if I didn't, this is something else that you could point out to your students, if I didn't draw this 10th road, then this neighborhood, these two houses are connected, we'll call them a neighborhood, why not, would be isolated from the rest of the connected houses, the rest of the graph. So that 10th road really is necessary, but I've intentionally drawn an extra road here, and you might want to do this as well if your students maybe aren't sure, and show them it's okay to make mistakes when you're thinking about things, because now you can say, wait a minute, hold on. What if the mayor was at this house visiting her constituents, or maybe this is a supermarket, and she wanted to get to this house here at the bottom of the town, the bottom of the map. Well, you could point out to your students that there's already this dotted line existing here that she could use to drive to that house. So she could drive over this road and that road to get to that house. And that road already existed. Or she could take your new expensive road that you just built, going this direction here, driving past her friend's house here to get to the last house at the bottom right-hand corner of that neighborhood. And so really it seems redundant, this road that we labeled 2, we don't actually need that one. So this isn't the least number of roads we needed in order to connect all of the houses and all of the neighborhoods. So actually, I don't need that tool. Sorry. We can eliminate this road, and you can go through and relabel all of your roads. We can count this. This is 1, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9 roads. Now it seems that we've connected our houses with 9 roads. And you could check and ask your students, is this the least number of roads? Is there any road that we built that if we remove, the houses are no longer connected, that they're now disconnected in some sense? And you can invite your students to try disconnecting houses and stuff like that. Toying with this idea and thinking about it is probably really helpful to think about. Okay, so we've done that. So I think the least number of roads that we would need to connect each house in this town would be 9. Please check to see if you can find a lower number. Okay. Or feel free to prove that that is the lowest number. I don't know how. If you do, that's great. All right, so that's exercise or puzzle C part 2. We've met the mayor's challenge, and I think we've come up with a solution that gives the most number of roads for the least price, the best connection for the least price. Okay, let's look at the next part of this puzzle, part 3. This map has 4 connected zones. Let's call them neighborhoods. I mean, it kind of makes sense. We're talking about houses and roads. We can call it a neighborhood or a subgraph. This part of the subgraph is a completely connected subgraph. Don't need to know about that, but from each one of these houses, I could get to either other house in the neighborhood because there are 2 roads from each house, and there are only 3 houses in this subgraph. Anyways, so you want to invite your students to identify the zones or the connected subgraphs or the components or the neighborhoods, which is probably a better word to use, by maybe circling them, but remember you're going to be connecting them with roads. So I'm not sure how you're going to be doing this, but maybe remind them to leave some room to draw roads in between. You want to identify the neighborhoods and then maybe identify the isolated houses in some way. Okay, so the map has 1, 2, 3, 4 zones and 1, 2, sorry, there's lint on my monitor, 3 isolated houses. And you can have them draw the neighborhoods and the isolated houses. Congratulations, we did such a good job at the previous town that the mayor has recommended us to the city council in the big city. And now we get a promotion. We're now the city planner in this bigger city, but this bigger city has a bunch of neighborhoods that need to be connected and a few isolated houses. And the city council has asked us to work the miracle we worked in the previous town by connecting these houses and these neighborhoods with the least number of roads. Okay, so now we have to figure that out. A useful observation that you might want to lead your students into making is that if I wanted to connect neighborhood 1 to neighborhood 2, well, I could draw a road between those two houses at one of the lowest points in either of those two neighborhoods, or I could connect these two houses here or these two houses here. Again, thinking about different choices you can make and maybe why you want to do that. Or I could do something like connect this house to that house and connect that house to that house. Again, you might want to point out that if you ignored the rest of the map and instead considered the mayor driving from this house to this house in the other neighborhood, she could drive all the way this way, or she could drive all the way this way. And so maybe one of those roads are redundant and we don't need it, and it won't give us the least number of roads. So we don't need all of those roads. And as a matter of fact, between any two neighborhoods, you only need one road. Because if I connect these two houses here, like so, then the mayor, if she starts off in this house, she can get to any other house in the other neighborhood. And maybe you could draw like the path of her car going along roads to demonstrate that, depending on what you think your students will resonate with. Okay. So we've identified neighborhoods, we've identified isolated houses, and maybe we've talked with our students and got them to think like, well, we don't need more than one road between any two neighborhoods. So really this problem is like connecting 1, 2, 3, 4, 5, 6, 7 things. And between any two neighborhoods, we really only need one road. So let's just choose, I don't know, this road here, this road here, this road here. And it really makes sense to draw a road between the closest two houses, but that's not necessary. These two houses, and we can't leave house number 3 all in its one sum over there. We want to bring it into the rest of the city. Okay. Now you could ask about if you could drive between any two houses in the city. As a city planner, you want to make sure you can get anywhere you need to go. Let's see, what else? Oh, and is this the least number of roads possible in order to connect all of the houses in the city? So again, maybe count the number of roads, say how many is that? And then there's a bonus opportunity here. We can learn a little bit about a field of mathematics called combinatorics, which is really just a fancy word that mathematicians like to use for counting things. another example of this thing is like a really simple problem. Like, for example, if I hold up my hand and I ask how many marbles can I hold between my fingers? And maybe at your desk, at your table, you have with your students, you have markers or something like that, and you can put markers between each of your fingers, and you can't hold a marker on the outside of your pinky, and you can't hold a marker on the outside of your thumb unless you're really talented. If not, then it's going to look something like this picture here. Wonder whose beautiful hand model this is. Anyhow, and you could say like, well, look, I could hold one marble between these two fingers, a marble between these two fingers, a marble between these two fingers, and a marble between these two fingers. Let me draw a picture here, like so. Beautiful. There's that. And say, well, notice I only have 5 fingers. People usually only have 5 fingers. And we can hold 1, 2, 3, 4 things. You only can hold as many as spaces between your fingers. Wait a minute, that's kind of a similar scenario here. We're only counting the spaces between the neighborhoods or isolated houses. And we notice that we have, we're connecting 1, 2, 3, 4, 5, 6, 7 objects, neighborhoods or houses. And we have 1, 2, 3, 4. I know it's getting cluttered here, sorry. 5, 6, or the number of objects counted minus 1 spaces between the objects that we're connecting. Okay. Now you can use this insight and say, well, is that true for any number of objects we want to connect? Can you reason about this without drawing anything or without writing anything down? An analogy, a way you might be thinking about that is like, maybe you can talk to them about like how many marbles you could hold between your fingers or markers you can hold between your fingers, whatever you have at your disposal. And then now we could ask them about like the slightly more complicated problem of what if you had a map with 20 connected zones or 20 neighborhoods and 43 isolated houses? How many roads would you need, or what's the minimum number of roads you would need in order to connect all those houses? Well, now with our new counting technique where we just count the number of things that we're connecting and subtract 1, this is really easy, and hopefully your students will see this and you can encourage them to maybe build on and apply the more abstract counting technique that you showed them to this larger problem where now you have 20 connected zones plus 43 houses. That's 63 things you need to connect, or 63 fingers, and you can hold only 62 markers between them. And so you only need 62 roads to connect all of these objects, which is a wonderful insight to have. Okay, I'm stoked about this puzzle. I hope you guys are stoked about this puzzle. This is going to be fun. Look forward to seeing everyone working on this with the students and on Monday. Until then, au revoir.